So hello and welcome back to this. Here we are going to solve the second category of the problem based on the Lagrange's mean value theorem. The problem will be like this: prove that some inequality will be there, and we have to prove this inequality, and hence we have to show some another inequality. This is not mandatory. Sometimes you will get question like this only, and sometimes there will be both parts will be there. So let us see how to solve this kind of questions. So to solve this kind of questions, first of all, from the given inequality we have to check what is the function f of x. So to check that we have to see the middle part. The middle part is tan inverse of b and tan inverse of a. So here the f of x will be, here the f of x will be what? F of x is equal to tan inverse of x. So this function we are taking here, tan inverse of x, and for this function we first of all apply the Lagrange's mean value theorem. So to apply, first we will check the continuity of this uh, function f of x, and to check the continuity, first of all we will see a f of a is equal to tan inverse of a, and f of b will be what? Tan inverse of b. So we can see that for any positive number, in addition to this uh, problem, we also get one more condition of the value of this a and b. So this a and b values, actually these two values lies between 0 and 1. So we know that tan inverse of 0 is what? 0, and tan inverse of 1 is what? Pi by 4. So for both these numbers we get the answer between the 0 and pi by 4, which is a real answer. So that's why this f of x, I can say it is a continuous function. So in addition to this, there may you will get the condition like 0 is less than, a is less than, b is less than 1. This kind of condition also you will get. So from this we can see that tan inverse of 0 is 0, and tan inverse of 1 is pi by 4. And from these two conditions we can say that for any number a and b which lies between 0 and 1, there the answer for this tan inverse will be valid, and that's why it is a continuous. Then second condition is about the differentiability. So to check the differentiability, first of all we have to take the differentiation, that is f dash of x, and it is equal to 1 upon 1 plus x square. We know that derivative of tan inverse of x is what? 1 upon 1 plus x square. And this definitely, this differentiation also exists for any number. If I put 0 here, it will be 1 upon 1. If I put 1 here, it will be 1 upon 2. So for any these two extreme numbers, the f dash of x value exists. So that's why we can say the given function is also differentiable within a comma b. So once you know this, then we have to apply, we have to choose the number c belonging between a comma b, such that f dash of c is equal to f of b minus f of a upon b minus a. So here, if I put all these values, like we have f of a, f of b, f dash of x, and also we have a and b. A and b are just a and b only. We don't have any numbers for a and b. So if I replace this, f dash of c will become 1 upon 1 plus c square, isn't it? X replace with c, and you will get f dash of c here. So this is equal to f of b, you can check here, it is tan inverse of b, and f of a is what? Minus tan inverse of a. Here you can check it, f of a, f of b, and this divided by b minus a. So here we have to keep this as it is. Okay, up to this we have to keep the solution as it is, and then we have to try something else, that is the inequality part. So that inequality part is what? A is less than b, and c belongs to a and b. That means what? the C value comes in between A and B. That means A must be less than C and C must be less than B. This is the meaning of this. C belongs to A and B means what? C must be in between A and B. It must be greater than A and it must be smaller than B. So this inequality we have to take it up to 1 upon 1 plus C square. We have to make in the center we have to make something like this, and to make it let us continue this. So first part we are going to do is we are going to do square of all the three terms. If I do A square, C square and B square, so there will be no change in the inequality as all these three numbers are positive numbers between 0 and 1. So if I do the square of all these three numbers, the inequality sign will remain as it is. Then I will add 1 into all these three terms. So if I add it, it will become 1 plus A square less than 1 plus C square less than 1 plus B square. By adding 1 into these numbers, also the inequality does not change, isn't it? Then we want this term, in the middle term we want 1 upon 1 plus C square. So that's why we will take the inverse of all these three terms. 1 upon 1 plus A square, 1 upon 1 plus C square, 1 upon 1 plus B square. So if I take the inverse of these three numbers which are positive numbers, and if I take the inverse, definitely the sign, inequality sign will change. It will change its direction. Okay, so whatever the number, the bigger number comes on the denominator, the whole number will become smaller. So that's why the bigger number comes in the denominator, it will be smaller than this one. So the inequality sign will change. So here what we are going to do, once we get in the middle f dash of C term, then we are going to replace this term, this whole term we are going to replace with this one. And if I do that, I will get 1 upon 1 plus A square greater than, for this 1 upon 1 plus C square, I am putting this term. That is what? Tan inverse of B minus tan inverse of A divided by B minus A, and the other term, that is right hand term, will remain as it is, that is 1 upon 1 plus B square. Then if I multiply B minus A throughout, there will be no change because this is again a positive number. So I will definitely get here a B minus A upon 1 plus A square greater than tan inverse of B minus tan inverse of A greater than what we can say B minus A upon 1 plus B square. Now this one is similar to this, only the thing is this term they have written on this side and this term written on that side. So we will write it in that way only. B minus A upon 1 plus B square is less than, see, this term is less than tan inverse of B minus tan inverse of A is less than B minus A divided by 1 plus A square. Got it? So this is what exactly what we have to prove. So hence we can say that this term hence proved, we can say. And again, in addition to this, we have to prove this inequality. So a little consideration will show here that by choosing the value of A and B, we can get this inequality. So what should be the value of B? You can check here. Here we have this 4 by 3, isn't it? Tan inverse of 4 by 3, and it is a positive number, so definitely this will be the B value. Here B will be equal to what? 4 by 3. Now this tan inverse of A is minus here, which after multiplying, if I multiply tan inverse of A throughout this inequality, then it will be positive on this and this side. So here clearly I can see pi by 4 is added on both sides. So pi by 4, what is pi by 4? It is tan inverse of what? Pi by 4 is tan inverse of 1, isn't it? Tan, because tan of pi by 4 is 1, so tan inverse of 1 is what? Pi by 4. So from this we can see that pi by 4 is nothing but tan inverse of 1. That means the value of a is equal to 1. So if I put these two numbers back into this equation, I will definitely get the required answer. So I will put here the value of b is 4 by 3 minus a is 1 upon 1 plus b is square of 4 by 3 is less than tan inverse of b, that is tan inverse of 4 by 3, minus tan inverse of a, that is tan inverse of 1, less than b minus a is nothing but 4 by 3 minus 1 divided by 1 upon square of 1. So this is, if this one, if I simplify, I will get the same inequality. Here you can check 4 by 3 minus 1. So 3 I will cross multiply here. So 4 minus 3 is 1. So this whole term will become 1 upon 3. So here I will get 1 upon 3 divided by, this will become 16 upon 9. Square of 4 is 16, square of 3 is 9. So it will be 16 upon 9, and if I do the cross multiplication, I will get 9 plus 16, that is what, 25 upon 16. So here I will get 25 upon 16, isn't it? And less than, I can say it is tan inverse of 4 by 3 minus tan inverse of 1 is what, pi by 4, less than this term, again I will get what, it is 1 by 3 here, and divided by, it is 1 plus 1 is what, 2. So further if I simplify this, and I will get this as, this will become 16 divided by 3 into 25. 3 into 25 is what? 3 into 25 is 75.